This is the Math 990 Module 6 review. First, we're going to take a look at this problem number 1. So we've got the product of two consecutive odd integers is 143. Find all such pairs. Now we have to remember what product means. Product is going to mean multiply. And if you remember back from a couple chapters ago, two consecutive odd, we would represent like this. The first one is x. To get to the next odd integer in a row, we just add 2. So the next one would just be x plus 2. Sorry, I'm recording this late at night. I guess you caught me yawning. Okay, now we need the product of those integers. So x times x plus 2 is going to equal 143. So that's how we want to set it up. Now it wants us to find all the integers, so basically we need to solve this. So first let's go ahead and distribute this x through. So we get x squared plus 2x equals 143. When we're solving a quadratic equation, we want to get all terms on the same side and set equal to 0. So let's go ahead and minus 143 from both sides. So those cancel. I now have x squared plus 2x. Notice that 143, it's not a like term, and so it'll just be minus 143 equals 0. All right, now we've got it set up, and we can factor this. Because the number in front of x squared is just 1, or nothing is written there, we can just kind of go for it. We can get our two sets of parentheses, make sure we have it equal to 0. We know to get x squared, we're going to have x times x. And then we've got to get a negative 143. So with 143, we've got to kind of look for numbers that are going to go into that. If there are two numbers in a row, it'll be close to the square root of 143. So let's see, what is the square root? The square root of 143 is, it's not 5. Got a new calculator. Okay, it says it's about 11.9 or 12. So I might try doing like 143 divided by 12 or 11, numbers around there. Well, if you do 143 divided by 11, you're going to get 13. So that one does go in evenly. So when you get a number like that, you can just start trying numbers, 7 and 9 and 11. Now, they have to multiply to be a negative 143 and add to be 2. So if they multiply to be a negative number, we know one has to be negative and one has to be positive. Because when we multiply two numbers together to end up with a negative, you need one of each. But they have to add to be a positive 2, and so that tells us this bigger number, the 13, will be positive, and the 11 will be negative. So let's just check that. Negative 11 times 13 is negative 143. Negative 11 plus 13 is a positive 2. So we'll have plus 13 and then minus 11. Okay. Last step here is we want to set these equal to 0 and solve. So x plus 13 equals 0, minus 13 on both sides, so we get x equals negative 13. And then similarly, x minus 11 equals 0. Oops, add 11 to both sides, so x just equals 11. So those are the two answers we got, but it's kind of weird because 11 and negative 13 are not consecutive odd integers. So basically what has happened is we've gotten two different x values that will work. So one of them is 11 and one of them is negative 13. And so what we can do is just put them in each of those x spots. Think of each of those as kind of the start of one of the pairs. So we do 11 plus 2, we get a positive 13. Negative 13 plus 2, we get a negative 11. Now I would check both of these and make sure that the product of these is 143 and that they're two consecutive odd integers. Well, 11 and 13 are consecutive odd because it's one after the other. For odd numbers, 11 times 13 is 143. And then similarly below. So anyway, that's how I would recommend doing that first problem. Okay, let's look at number 2. We've got 25t squared minus 90t plus 81. So there are a couple ways to look at this problem. One is you could just do the rainbow method where you're multiplying 25 by 81 and then find numbers that go into 90. But something I'm noticing here is we have perfect squares on either end. And so because of that, I'm just going to try to see if this would work if we just did, okay, square root of 25t squared is 5t. So we'd put 5t there. Square root of 81 is 9. Now since it has to multiply to equal a positive 81, we know they both have to be the same. Either positive 9 times positive 9 or negative 9 times negative 9. However, they have to add to be negative 90. And so because of that, they both would have to be negative. So right at this point, this is just an educated guess. So I would recommend just quick multiply it out, see if it works. So 25t squared minus 45t minus another 45t gives us minus 90t plus 81. So that worked. You could also write it as 5t minus 9 squared. Be on the lookout for these because if you can recognize them, you can see it really does make it a little bit easier. However, if you didn't recognize it, I'm going to show you how you could do it just similarly to how we'll do number 3. So number 3, we need to factor completely. Now this one, we do have a number in front of the x squared, and they're not, 4 is a perfect square, but 6 is not. So we're going to have to go for this one. So first thing I look for is a greatest common factor. Is there any number we can factor out of all 3? Well, no, there's not. So we're just going to do rainbow method. This is where we multiply 6 times 4. So we do 6 times 4 gives us 24. And then we want factors of 24 that will add up to 3. Okay? We know they both have to be positive. So, let's list them all. We've got 1 and 12. They're both positive, not going to add up to 3. 2 and 8, oops. Oh, man. Hate it when you realize your brain's tired. Okay. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Those are all the possibilities, and none of those add up to 3. So this one is just going to be not factorable. So we're just going to write prime. And if you're not convinced, you can also, try a few and see if you can get it to work out. But this one, I like this one because it's a straight way to do it. You just say, okay, 6 times 4, 24. None of the factors add up to 3 because they both have to be positive, so not factorable. Okay, let's look at 5. So let's see if 5 is factorable. First, greatest common factor. Well, it looks like a 2 will come out of that. So 2, I'm left with z squared minus 100. Okay, at this point, I want to see, can I factor z squared minus 100? Well, these, z squared and 100 are perfect squares. And so we can do those using difference of squares. If you remember difference of squares, if you have 2 perfect squares, take the square root of each. So we'll have a minus b and then a plus b. So we're going to do that here. We'll still have our 2 out front. We'll have z, square root of z squared is z. Square root of 100 is 10, so z minus 10. And then z plus 10. Okay, neither of these is going to go further, and so that would be our final answer there. Okay, 6. 6, we need to identify the greatest common factor and then factor that out of the expression. So we need the biggest number that will come out of all of these. Well, we can see they're all even. So if I divided 2 out of here, I'd get 13 12, and 19. And I don't think they're going to have any other factors. So we're going to have 2. For a's, the least I have is a cubed. So we can do that. B's, the least I have is b. And this one doesn't have a c. So that's going to be our what we factor out. So let's go ahead and write that here. 2a cubed b. If we divide that out of the first one, we'll have 13. A cubed is gone. We'll have 1b left and c to the 8th left. Next term, divide out 2, we'll have 12. A cubed is gone, so we'll have 1a left, and then b to the 4th. And then the last one, 38 divided by 2, we'll have 19. A to the 7th, we get rid of 3 of those a's, so we have a to the 4th. The b is gone, and c to the 6th. So you just want to take it one at a time, make sure you look at it carefully, and if you're unsure, you can also multiply it back through and make sure it looks like what you started with. Okay, 7. This one's a little different because it doesn't have a constant term, right? A lot of times we'll have something in this form, ax squared plus bx plus c equals 0. But in this case, there is no c. So just like we always do, we want to look for greatest common factor first. So look at that. Well, greatest common factor is going to be a p. So we can factor out p squared divided by p, we have p left. And then plus just a 3, still equal to 0. Now we want to set each of these equal to 0. So we say p equals 0, and we want to set p plus 3 equal to 0. So we minus the 3 on each side, so p equals 0 and negative 3. Those are our two answers. All right. So 8, actually, we're going to skip 8. Now we'll look at it. So 8, we want, since there's only a 1 in front, or basically no coefficient, well, it looks like no coefficient, but it's really a 1. What we can do here is just look for factors of positive 54 that add up to negative 15. So 54, you might have to kind of think through the factors, write them all out. But I'm thinking 9 and 6. Now, they have to either be both positive or both negative because they have to multiply to be a positive 54. So either positive 9, positive 6, or negative 9, negative 6. But since they have to add to negative 15, we know they've got to be negative. So it'll be those. So we write our y out front, and then minus 9, minus 6. And that's it. That would be our final answer. Put in that box. Okay, let's skip 9, 10. See if you can see any perfect squares there. Let's look at 12. Actually, I'm going to start a new video.